Alright, now we're going to look at some dividing of rational expressions. What we're going to need to do first is change our division problems into multiplication. And in order to do that, just like we would do with any fractions, we would leave the first fraction, or in our case our first rational expression, as it is. We'll change our division to multiplication, but we'll take that second fraction, or in our case that second rational expression, and flip it, turn it upside down, reciprocal. Alright, so let's go ahead and do that. We'll leave this first rational expression just like it is, 2x squared plus 12x over x squared minus x. We're going to change that division to multiplication, and now we're going to take that second rational expression and flip it. We use the reciprocal. So now it becomes 4x to the third minus 4x all over 3x plus 18. At this point, it's just like the multiplying rational expressions that we looked at earlier. We're going to have to go in there and factor numerators and denominators for both of the rational expressions. So I'm going to start with that 2x squared plus 12x. Notice it has a GCF, greatest common factor, and that is a 2x. So 2x times what will give me the 2x squared? In that case, it's an x. 2x times x is 2x squared. 2x times what will give me that 12x? Well, in our case, that's going to be a 6, because 2x times 6 would give me a 12x. So at this point, I'm done factoring my numerator. Now I'm going to go down to the denominator and factor x squared minus x. It also has a GCF, or greatest common factor, and it's x. X times x will give me an x squared, and x times a negative 1 will give me that negative x. So I've just completed factoring my denominator. Now I'm going to go to that second rational expression, and I'm going to go ahead and factor it. 4x to the third minus 4x has a GCF, and that is a 4x. 4x times what will give me 4x to the third? In this case, that's going to be an x squared. 4x times what will give me a minus 4x? Well, that's going to be a minus 1 there. Now I'm going to go down to the denominator, 3x plus 18. That does have a GCF, and that's a 3. 3 times what will give me 3x? Well, that's an x. And 3 times 6 will give me 18. Alright. Now, it looks like I'm done factoring, but I'm not. If you look here, this x squared minus 1 can be factored as well. That we can do by using our difference of squares. This right here can actually be factored as x minus 1 and x plus 1. Alright, so we're going to go ahead and use those factors rather than this right here. Alright, go ahead and get rid of this. So again, the factors we're using are x minus 1 and x plus 1. Alright, so at this point I've got everything factored. Now I'm going to go through here and see what I can cancel out. I see an x and another x. I see an x plus 6 and an x plus 6. I see a x minus 1 and an x minus 1. And it looks like that's all we can cancel. So what I'm left with for my numerator is 2 times 4x times an x plus 1 all over 3. Now I'm going to go ahead and simplify that a little more. If I multiply 2 times the 4x, that would give me a 8x. Of course, I still have the x plus 1 over 3. Now I could leave it in this form here, or I could take it a step further and actually use some distributive property and multiply 8x times x, which would give me an 8x squared. Multiply 8x times the 1, which would give me 8x. And of course my denominator would stay a 3. So this would be another option of writing our answer. Alright, example number 2. We're going to divide the two rational expressions. And as I did with the first example, what we're going to do is change that division to multiplication. But by doing that, the second rational expression, we're going to have to use its reciprocal, or flip it. So, first rational expression is going to stay as it is, 5x minus 15 over 7x minus 14. That's going to stay. We're going to change that division to multiplication. And we're going to flip that second rational expression, or the reciprocal, and write it as 7x plus 21 all over 5x plus 10. Alright, so just like I did with my multiplying of rational expressions, I'm going to need to go in here and factor as much as I can. So if I start with that 5x minus 15, there is a GCF, and that GCF is 5. When I multiply 5 times x, I get 5x. And when I multiply 5 times a negative 3, I get a negative 15. Therefore, my factors are 5 and x minus 3. I'm going to do the same thing with the denominator. It has a GCF, and that GCF is 7. 7 times x will give me the 7x. And 7 times a negative 2 will give me that negative 14. So these are my factors of 7x minus 14. Now I'm going to do the same thing with the other rational expression. 7x plus 21 can be factored. The GCF there is 7. 7 times x will give me a 7x. And 7 times 3 will give me that 21. And then I'm going to go down to the denominator and I'm going to factor it. 5x plus 10. The GCF there is 5. And if I multiply 5 times x, I get the 5x. And if I multiply 5 times 2, I get a 10. So at this point, I've factored both my numerator and denominator for both of my rational expressions. Now I'm going to go in here and see what I can cancel out. I can cancel out this 5 with this 5. I can cancel out this 7 with this 7. And that looks like that's about it. That's all I can cancel out. Those are the common factors. So what I'm left with is x minus 3 and x plus 3. And down in the denominator, I'm left with x minus 2 and x plus 2. Now, I could leave it like this in its factor form. That would be okay. Or I could actually do FOIL and multiply those out and simplify that. I think that's what I'll go ahead and do. X minus 3 times x minus 3. If I go through FOIL, I end up with x squared minus 9. And for my denominator, x minus 2 times x plus 2, if I go through FOIL and I multiply those together, I end up with an x squared minus 4. So this would be another way that we could write our answer. Alright, last example we're going to look at. Just like I did with the other two examples, we're going to start off by rewriting this so that we can change the division to multiplication. And then we're going to take that second rational expression and flip it, or use its reciprocal. So the first one stays, x squared plus 5x plus 6 over x plus 7. We're going to change that division to multiplication. And we're going to take this second rational expression and flip it, or use its reciprocal, which is x squared minus x minus 56 over x squared minus 5x minus 24. At this point, I'm ready to start factoring my numerators and denominators. So I'll start with x squared plus 5x plus 6. This is a trinomial with a leading coefficient of 1. Therefore, the factors are going to be in this form here. We know that x times x will give me the x squared. Now I need factors of 6 that are going to add up to 5. Again, what can I multiply together to get 6 that also adds up to 5? In this case, that's going to be 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. Go down to the denominator, x plus 7. X plus 7 cannot be factored, so I'm just going to leave it as x plus 7. I'm moving on to the next rational expression, and I'm going to factor it. x squared minus x minus 56 needs to be factored. Notice I've got a trinomial with a leading coefficient of 1. Therefore, the factors are going to be in this form here. We know that x times x will give me the x squared. Now I need to know what are some factors of negative 56 that are also going to add up to a negative 1. What can I multiply together to get negative 56 but would also add up to a negative 1? In this case, that's going to be a negative 8 and a positive 7. Negative 8 times 7 would give me the negative 56, and a negative 8 plus 7 would give me a negative 1. So those are my factors. Do the same thing with the denominator, x squared minus 5x minus 24. Notice I've got a trinomial with a leading coefficient of 1. Therefore, my factors are going to be in this form here. We know that x times x will give me the x squared. The question is, what are the factors of negative 24 that also add up to a negative 5? Well, in this case, those two numbers are negative 8 and positive 3. Because a negative 8 times a positive 3 will give me the 24, negative 24. And when I add the negative 8 and 3, they add up to a negative 5. So at this point, I've done all the factoring. Now I'm going to go through here and see what I can cancel out. Let's see, I see an x minus 8 and an x minus 8. I see an x plus 3 and an x plus 3. And I see an x plus 7 and an x plus 7. Therefore, the only thing I'm left with is x plus 2. Therefore, when I divide those two rational expressions, I end up with x plus 2 as my answer.